In this video, we're going to be talking about example 3.3, where we're going to continue to the discussion of the Iowa test scores and normal distributions that we did in the last video. In this question, we're still looking at figure 3.10 of the distribution of Iowa test scores, but this time we're saying a score of 5.29 is one standard deviation below the mean. What percent of scores is higher than 5.29? So we're going to follow the same process as we did before, starting out by sketching out our normal distribution curve. We're using the one that we've already sketched. And the first thing that we're going to do again is, since we're interested in looking at scores higher than 5.29, we're going to locate 5.29 on our distribution, and we can see that it falls one standard deviation below the mean. And reading the question, we're looking at what percent of scores are higher than 5.29. So I always draw this little arrow for myself as just a visual clue of that's what I'm trying to sum up together, the percent that fall under that part of the curve. And now, since it's a normal distribution and since 5.29 falls exactly one standard deviation below the mean, whenever the value that we're focusing on falls exactly on a even multiple of standard deviations, we can use our 68, 95, 99.7 rule. So we're going to do that first by looking at what is the rule around one standard deviation from the mean. Well, values that are one standard deviation below to one standard deviation above the mean is 68% of the data. So this spread right here is 68% of the data, which means the remainder of the 100% of the data, those values that fall outside of the 68%, is 32. 32% encompasses everything below one standard deviation and above one standard deviation, whereas the 68% is things that fall between one standard deviation above and below. So we know that this piece here is 68%. In order to answer our question, we need to determine what the remaining piece of this above 5.29 is. And again, because the data is symmetrical, we know that this 32% is evenly represented, half below one standard deviation and half one above, so 16% on either side of one standard deviation. So if we now look at our sum, we know we have 68% falls here, 16% falls from here to the end, and therefore 68 plus 16 equals 84% of the distribution. And you can double check your work by saying, well, I know now below 5.29 is 16%. 100% minus 16% is 84%. Because remember, the whole distribution represents 100% of the data, so that's one way that you can always check that out.